So earlier in this course, in week 4, we talked about linear models. And a linear model is where you're growing with a constant rate of change. So something's increasing, like maybe a bank account where you deposit $50 every week or every month. So plus 50, plus 50, plus 50 over and over again, that would be linear growth. And we're going to learn about the difference between linear and exponential growth in this lesson. But before we jump into exponential growth, here's a little review of some linear growth examples. When you work a job where you are paid hourly, your pay goes up linearly with every hour you work. So if you work one more hour, you're going to get $13.50 more, $13.50 more, $13.50 more, if that's your hourly rate. It just keeps increasing by the same amount. Here's a little bit of a challenge question. What is the pay rate that's illustrated in this graph? It's not immediately clear what this is, but you could estimate. What you would need to do is locate a point on the graph, maybe this point right here, where the person looks like they worked about 25 hours and they made $300. If you make $300 and you work 25 hours, looks like you're earning about $12 an hour. Let's see what I wrote here. Okay, so here I used a different estimate. I went to the 10-hour mark and I estimated that it was at about $120. So again, I came up with $12 an hour. And it's okay if you're slightly off because you're estimating from a graph. An adult of average size burns about 112 calories for every mile they run. The relationship is linear. Every mile corresponds to 112 calories. So if you want to burn 1,120 calories by running, you would need to cover how many miles? 10. This got multiplied by 10, so they must have run for 10 miles. Good grief, we can't run for 10 hours. Most people can't anyway. But every time you run another mile, the calories burned increase by the same amount. So these are both examples of linear growth, but now we're going to show you that exponential growth is a little different. In exponential growth, each output is found by multiplying the previous output by a growth factor. This type of growth has a constant percent increase. So we learned about percent increase in the previous lesson, and now we are looking at what if you grow by the same percent over and over and over again. Linear growth is when you add the same amount each time. Exponential growth is when you multiply by the same number for equal time increments. And I think this will make sense later. You may want to come back to this after you've seen some examples. Let's look at cell division. Single-celled organisms go through a process called mitosis, where each cell divides into 2 cells. So this is trying to be a model of cell division. We go from 1 cell to 2 cells, and then each of those splits, and then we have 4 cells. And then when each of those splits, we have 1, 2, 3, 4, 5, 6, 7, 8 cells. So we doubled, 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 and we're going to double again on day 4. So that should be 16 on day 4.